Good afternoon, everyone. So this presentation is really about Lustre security. Probably some of you are from the big data area and are considering moving from HDFS to Lustre and have specific requirements regarding their workflows. Maybe some of you are from the more traditional HPC area and have requirements regarding performance impact of security. So this presentation is for you. When we start working on Lustre security, we gathered requirements from our big data and HPC customers. Here is a list of the requirements we gathered. So what I'd like to do is to conduct a little survey here in this room, in the audience. I know some of you voted less than a week ago, but I promise this vote will be much less controversial. I just want you to raise your hand when I mention one security requirement, if you consider that this requirement is the most important or the most interesting for you. So the first requirement is authentication. So it's authentication of nodes, but also users. So please raise your hand if you think this is the most important or the most interesting for you. Okay, only you. Okay, thank you. So the second requirement is access control. So discretionary access control, but also mandatory access control, which means SE Linux. So who thinks this is the most important feature for a parallel file system like Lustre? Okay, only a few of us, thank you. Then we have multi-tenancy, so the ability to provide, to support different populations on a single Lustre file system. Okay, okay, it's quite balanced so far. Then we have encryption, so encryption on the wire, but also encryption of data at rest. Okay, okay, thank you. And last security requirement is audit. Okay, so as I can see, the most interesting are access control and multi-tenancy. I will first go quickly on authentication. So thanks to Kerberos support in Lustre from Lustre 2.8, we are able to authenticate users that access to files hosted on Lustre file systems. First, users have to authenticate with their own Kerberos credentials and then can access the Lustre files based on their UID and GID. But more importantly, thanks to Kerberos support, we are able to authenticate nodes that are part of our Lustre file system. By default, if you have a node that is connected to the interconnect network and if you know the address and the name of your file system, well, you can just mount Lustre as a client, which means that you will be able to access an existing Lustre file system. But even worse, you can add a device of your own as a new target to an existing file system. So it means that legitimate users will then store part of their data on your newly added target. So in order to prevent this and to be protected against that kind of security breach, it's possible to assign roles and credentials to every node in a cluster and only allow actions from these nodes depending on their credentials. So again, thanks to Kerberos authentication. Now let's talk about access control. So discretionary access control is pretty straightforward. This is UNIX rights enforcement. In Lustre, this is done on MDS side. And just to mention that it's possible to strengthen access control in Lustre with the root squash feature. So it's simply the ability to map the root user to somebody else, to another user, in order to prevent root user from having all privileges on the files hosted in Lustre. More interesting, according to the little survey, is mandatory access control, which means SE Linux. I don't know if you are really familiar with SE Linux, so let me go into some details. The first main SE Linux policy is the targeted policy. So basically, the aim of this policy is to protect the OS. To that extent, the targeted policy will create like sandboxes, which are called domains, in which users and processes will be confined, so they will not be able to access other parts of the system. From Lustre 2.8, we support having SE Linux targeted policy enforced on Lustre client side. The second major SE Linux policy is MLS, for multi-level security. So MLS is more about protecting the data. It comes in addition to the targeted policy, and it defines security levels. So it's like in the military, you are assigned a security level, and the policy says that you can only read files at a level below you and write files at a level above you. Again, from Lustre 2.8, we support having SE Linux MLS policy enforced on Lustre client side. Both policies have in common that they require to store the security context permanently. So in Lustre, we use an extended attribute for this purpose. But the main difference with MLS is that as its purpose is to protect data, in any distributed file system, we really need to make sure that SE Linux is properly enforced on all the clients that are accessing the distributed file system. If it's not the case, it means that from this node, MLS will not be enforced, and so data will not be protected. So we developed a new feature in Lustre in order to control that all Lustre clients properly enforced SE Linux. So on client side, we calculate an SE Linux status that will be sent with every single request to the servers. And on server side, we compare this information with a reference information that represents what should be the SE Linux enforcement on the client nodes. And if they do not match, it means that SE Linux has been tampered on the client node, so we decide to refuse connection from this client. So this feature will be available in the community release of Lustre 2.10. Okay, now let's move to multi-tenancy. So to achieve multi-tenancy, we designed what we call Lustre isolation. So it's the ability to provide isolated namespaces from a single Lustre file system. To achieve this, we combine different features. The first one is containers or VMs, which means that we want to mount Lustre clients from containers or VMs. Then we use Kerberos in order to authenticate the Lustre clients that are mounting from containers or VMs, and we use subdirectory mount so that depending on Lustre client's identity, the client will be only presented a portion, a subdirectory of the Lustre file system, and will not see the rest of the Lustre file system. So this feature will be available with Lustre 2.10 community version. Here is how it works. So as in any Kerberized environment, the Lustre client that mounts from a container or a VM first need to connect to a Kerberos server in order to retrieve its credentials. Those credentials will be presented to the servers when mounting Lustre, so that the servers make sure of the client's identity. Then on MDS side, we will look for the Lustre client identity into the node map in order to fetch the associated file set in the Lustre lingo, which is the subdirectory. So automatically, when a client mounts Lustre from within a container, it will be presented only the subdirectory that was defined on Lustre server side. So which means the container or the VM will only see a portion of the global Lustre file system. So it's really cool because it avoids having to statically assign resources on Lustre on clients for different populations. You can just dynamically instantiate containers of VMs and mount Lustre from them. So really, this makes Lustre multi-tenant. We want to take this feature a step further and be able to isolate users or groups that are part of the same population. We want it to be flexible, so it means we want to be able to flexibly adjust the access capabilities, and still we want to share the same file system root. So to achieve this, we decide to enforce SELinux MLS inside for the clients that are running in containers or VMs. So really, because what we want to achieve is really enforce data confidentiality. Okay, so let's move on to encryption. Thanks to Kerberos support from Lustre 2.8, we are able to provide wire encryption, on-the-wire encryption for Lustre. So it means that Lustre client, on Lustre client side, we will encrypt RPCs before they are sent to the servers, and on server side, RPCs will be decrypted and then processed normally like any regular RPC. Of course, it has a cost. It makes Lustre IOs really CPU bound. I have put here some figures that are quite old, more than 1 year old, where we could see like 80% performance drop on bandwidth performance and 40% performance drop on metadata. So it's quite clear that rerunning the same benchmarks with current CPUs would give better results, because again, this is really CPU-intensive activity both on Lustre client and Lustre server side. But it's available now. Now, if we want to provide encryption of data at rest, we can use secure disks, so disks that will encrypt data directly. But we are also thinking about providing encryption at the Lustre level. So you may know that Lustre uses a variation of ext4 as its backend file system, and ext4 has encryption capabilities. So we want to leverage this and provide encryption at the Lustre level. We want encryption keys to be only accessible on Lustre client side. So it means that data would be encrypted and decrypted by the client. But for data, we want to provide two different mechanisms. In one case, we would handle encryption and decryption on server side, so that we save CPU cycles on Lustre client side. But the drawback is that data that is sent over the wire between Lustre clients and Lustre servers is not encrypted yet. And we want to also provide another variation with when encryption is handled on Lustre client side. So of course, it will cost more CPU cycles on client side, but all data that will be sent between clients and servers will be encrypted. So we are working on this. And last feature is audit. So given that we support SE/Linux on Lustre client side, we could use the SE/Linux auditing facility to have auditing in Lustre. It requires to consolidate all audit logs from all Lustre clients. So we are also thinking about using an existing Lustre feature, which is called Lustre changelogs, and use it for auditing purpose. Changelogs are cool because they gather all access information made on Lustre. It's already consolidated on the MDS side, so it's really interesting for auditing purpose. The thing is, it lacks the user information. So we would need to enhance the Lustre changelogs feature to add this user information and make it suitable for auditing purpose. Okay, so as a conclusion, here is a list of all the security features we have been working at DDN for Lustre. So that is the list of security and related features. So we have subdirectory mount and quota for subdirectory. We have all stuff related to isolation and Docker integration. And last but not least, we have the MLS support, enhanced MLS support in Lustre 2.10. And that's all that I have. Thank you. Do you have any questions?
Specifically using the AES type extensions to the opcodes and modern processors so that there's effectively no overhead?
So the figures were the base case, that is to say when using ES-NI instructions in Intel CPUs. So with, for instance, if you use DES encryption, it's even worse and it's less secure. So the best performance was with AES 128. With 256, the performance is poor. Okay, thank you.
Yeah. Is there any performance impact for these other features you have named?
Regarding
like user Node authentication and user authentication.
Okay. Yeah, for instance, regarding SE/Linux support. So as we have to, as I said, we store security information permanently into an extended attribute. So it has a cost regarding file system operations. We made some really interesting improvements in performance regarding SE/Linux support. And for instance, thanks to these optimizations, we only see a 5% performance drop on file create when SE/Linux is activated on SE/Linux on Lustre client side. So the major impact is on when you just stat files, for instance, because you have to retrieve extended attributes and then do the stats. Yeah.
One very quick one, which I may have missed. Quality of service on the multi-tenancy?
To achieve, so the question is about QoS in multi-tenancy. So we try to use the mechanisms provided by containers to achieve quality of service. So for instance, to balance I/O bandwidths between different containers, doing IOs on Lustre, or to privilege some containers against some others. But it doesn't work because apart from when you use encryption, Lustre is not CPU bound activity, doing IOs on Lustre, I mean. So, and the mechanisms provided by containers are based on limiting access to the CPU. So to have quality of service, we recommend using another Lustre features that is made by DDN, and that is not directly related to multi-tenancy. This is the token bucket filter policy that was developed on top of network request scheduler. So network request scheduler is a Lustre feature generally available, and basically it works on creating policies and assigning priorities to different based on the Lustre client identities.
Any other questions? Great. Thank you, Sebastien.
Thank you very much.
All right.